Hello students. Next let us look at a problem with the help of nodal analysis. In this problem what is important is that we have got a dependent source. So how will we do dependent source problems? That is what we are going to look into this section, this problem. So let us look at the problem. Find the voltage across 5 ohm resistance. That means we have to find out what is the voltage across this. So if we have to find out the voltage across this, basically this and this, whatever is the voltage, this minus this will give us the voltage across 5 ohm resistance. Now the first thing we can solve this using mesh analysis also, but since it's nodal analysis that we are trying to study, here we will do it using nodal analysis. So first things first, we have to first define what are going to be the nodes. So as you can see, this whole complete thing will become one node. Let me write that node here. I can write that node anywhere. I can even write that node here. That is not matter, because if I draw this node, this both nodes are same because there is no element in between here. So I will just draw one node. And which all are the branches that are coming? This is one, this is the second one, and this is the third one. So let me mark the second one. Generally I mark it down, so again I'm going to draw it down. Okay, now this is, as you can see, this is a voltage source, and this voltage source means here we will have a node. That node will be basically having a value of minus of 30 I1. So that we will see. Okay, so other than that, there is another node here. If we want, we can write that node together. That node also we can write, but I will avoid that. Why? Because since there is no third branch here, it's as good as to consider that these two resistance 20 and 10 ohms are together, so that we will get 30 ohms here. Okay, so I am again going to reduce the number of nodes. So there is a node there, but I'm not going to find out that. So there is actually only one node here, so I will write it V1. So this is the first node. Second node I could have written here, but I'm not going to write because it's going to be one and the same thing. As I told you, three branches are there, then there is a point in writing node. Otherwise we can simply write it as a series resistance 20 and 10 ohm together. Okay, so now I'm straight away going to go from here. I1 is basically, first I have to define. So dependent source from figure, 30 I1 is equal to 30 times I1. Now what is I1? I1 is the current that is flowing between V1 and 50 volt through the total resistance of 20 and 10, that is 30 ohms. So I can write it is higher potential is V1 minus lower potential is 50 divided by total divided by 30. 20 plus 10, 30 volt, 30 ohms. So in a way I will basically get 30 and 30, I will cancel out, and I will get V1 minus 50. So for me, all I have to do is write this particular voltage point as V1 minus 50. So this is the first equation. Then I am going to write KCL at node 1. So the total number of branches are 4. First is incoming, so plus 2 amperes minus, so everyone might be thinking, what is going to be the voltage here? Well, as I told you, these both nodes are same. So it's as good as writing V1. So V1, here it will be V1, here it is reference, so 0. So minus of 5 minus 0. So I will write 5 minus 0 divided by, not 5 minus 0, sorry. I will write V1 minus 0 divided by 5. Now actually for me there is no need to write 0. As you might have understood, 0 is anyway going to make no change. So from now on what I will do is I will not write 0. Whenever there is 0, I will avoid 0 because there is no point in writing that. So I will straight away write V1 by 5. So let me bring it close together. Okay, so minus V1 by 5. Then I am having the third branch, which is again it is going outside, so out of the node, so minus of V1 minus, this point is going to be 30i1, this point is going to be 30i1, and since it is negative polarity, so it is going to be minus 30i1. So 30i1 is already known in the first equation, it is already given 30i1 is V1 minus 50, so I will use that. So it will come as minus of, sorry, V1 minus of minus 30. So minus and minus will become plus, yeah, so minus and minus will become plus V1 minus 50 divided by the resistance, which is 10 ohms, minus, again it's an outgoing current, so minus, it is V1 higher potential minus 50 divided by 30. So I will not write ohms because it's an equation, so I will avoid the units. So now we are having this is equal to 0. I have to put the bracket here. So this is how the equation is looking like. Now as you can see very clearly, I have to multiply it with 30, 10, 5. If you would see, if I multiply only with 30, 30 and 5 will cancel off. 30 and 10 will again cancel off with some numerator. Similarly here also some numerator. So actually I will multiply it with only 30. Though I can multiply this whole equation with 30 into 10 into 5, I will avoid that. Okay, because it will become a very big equation. All the point in multiplying is basically to take away the denominator. So in that case, since 30 is divisible by 5, 10, so I will go for 30, multiply it with 30. So multiplying with 30, what will I get? So let me take it inside. So yeah, 30 into 2 is going to be 60 minus 30 and 5, we know that 6 into 5 will be 30. So I suppose for the benefit of those who don't understand, 30 divided by 5 will basically be 6 times. So it will be 6. So using that principle, so this one here will be 30 into 5 will be 30 divided by 5 will be 6 times V1. Then minus, then again 30 and 10, 30 divided by 10, we know that it is going to be 3. So we will use that. So minus of 3 times, so here it is V1 plus V1, which is 2V1. So I will again put a bracket 2V1 minus 50. Actually I should have taken 3 inside, but next step, no problem. Minus of the last part, 30 and 30 will cancel off, so it is going to be just V1 plus 50 is going to be equal to 0. So now if I take all the V1 together, so minus 6, here also I will get minus 6. So minus 6 is minus 12. then minus 12 plus minus 1 is minus 13. So I will get minus 13 v1, and all the other values will be 60, 60 here, 150 here. So 150 plus 60 is going to be 210, plus 50, 260. So I will write it 260. So plus 260 is going to be equal to 0. From here, basically I can straight away calculate what is V1. So I will bring this V1 the other side. So this will give me 260 is equal to 13 V1. What I have done, I have taken minus V1 the other side. So minus becomes plus. So it is therefore V1 is equal to 260 divided by 30, which will give me the answer 20 volt. So only one unknown was there, that was V1. So V1 we have found out, that is the only one that we had to find out, therefore we will get I1 also from it, no problem. So now final answer, therefore current through I guess it was 5 ohms. So this is the 5 ohms. So on one side of it the voltage is V1 and the other side it is 0. So it is V1 minus 0. So voltage across. So I have to write voltage across. Okay. So therefore voltage across 5 ohms is going to be equal to V1 minus 0, which is equal to 20 minus 0, which is 20 volt. So that's the answer. So as you can see here, since there was only one node to be found out, the question was very simple. Next, let us look at another problem, like just like this. Let us do another problem. So in this second question, find the voltage V1 and V2. So there are two unknowns, V1 and V2, so we should have two equations. So anyway, first, we will draw the currents. So I will draw this current arbitrarily in any direction. So suppose this is the current that we have drawn. Then I will write KCL. I have to write the value here for the question. The value of this one is V1. So what is this source? This is a current source having a value V1. Should not get confused. The value can be anything. It is the symbol that matters. The symbol is of a current source, so it is a current source having value V1. Okay, KCL at node 1. So here the first current is incoming, so 2 minus V1, higher potential minus lower potential, divided by 0.5, higher potential because the current is flowing from higher potential to lower potential. The direction of current will decide what is going to be the higher potential and what is going to be the lower potential. Okay, so higher potential minus lower potential divided by the resistance. The second is an outgoing current, so it is going to be minus V1 minus 0 divided by 0.25. Okay, then I am having the third current is also outgoing, so minus of V1 minus V2 divided by 1 ohm, and that should be equal to 0. I can multiply it with 0.5 as well as 0.25, but 0.5 is enough because it will cancel. with others. So multiply with 0.5. Why I multiplied with only 0.5? Because 0.5 will multiply with all of this. Not multiply, I want to get rid of the denominator, so 0.5 will do that. So I will write 0.5 multiplied with 2 minus v1 divided by 0.5 minus v1 divided by 0.25 minus of v1 minus v2 divided by 1. No need of writing 1, but you will just write it. Now 0.5 and 0.5 gets cancelled, so the equation become 2 minus v1 minus of 0.5 divided by 0.25 is, you can do the calculator, you can use the calculator, you can find out 0.5 divided by 0.25 and it will come out to be 2. So it will give 2 times minus of 2 v1 minus of 0.5 v1 plus 0.5 v2, that is going to be equal to 0. And from that, writing all the v1s together, so minus 1 minus 2 is minus 3.5. So I'll get therefore minus 3.5 v1 and v2 is plus 0.5 v2. The remaining is 2, which I take the other side to be minus 2. So this is my equation 1. That's my equation 1. Similarly, I can do the second one. At second node, so KCL at node 2. KCL at node 2, I will get incoming current, so plus v1 minus v2 divided by 1. Now I will not write 1, it's understood. Minus v1, so v1 is unknown, so I will straight away write v1. So the current is going down, so it should be minus of v1. Then again the last is also going outside, so minus of v2 divided by 1 is equal to 0. So there is no denominator here, so I will get the second equation straightforward. I will get v1 minus v1 will basically cancel off and I will straight away get v2. So as you can see, v1, so it is going to be v1 minus v1. v1 minus v1 is going to be 0. So v1 is not going to be there. What is now remaining is minus v2. So minus 2 times v2. Therefore minus 2 times v2 is equal to 0 or v2 is equal to 0. Since I have found v2, there is no need to use the calculator here. Therefore from equation 1 directly I will substitute v2, so minus 3.5 v1 plus 0.5 into v2 is 0, so is equal to minus 2. So therefore I will get, therefore v1 is going to be 2 divided by 3.5, minus 2 divided by minus 3.5, minus minus gets cancelled off, so 2 divided by 3.5, and that, using the calculator I can find out. So I just write 2 divided by 3.5. So that is the voltage V1. So according to the question, V1 and V2 we had to find out, we have found out. Thank you.